All right, so let's have a few more definitions. A simple group, and this is something which is very useful. We will find it very useful later on. So if G is a group whose only normal subgroups, it can have other subgroups, but normal subgroups are G itself or the identity element. So then we say G is a simple group.
So there is just like no improper normal subgroups.
Well, it's, yeah, improper, I don't think, yeah, exactly. I don't think that's a term, but that is the essence. But you might say, why didn't we define, a simple group as a group which doesn't have a proper, which doesn't have which has no proper subgroups, right? That the problem with that is that when you do discrete groups and also like continuous groups, you will see that having like subgroups, like proper subgroups, is very common. A lot of times, so having a proper subgroup itself doesn't really give you a very useful way of, defining, so simplicity is a little bit more complicated. It is asking for the subgroup to be if the subgroup is, if it doesn't have any normal subgroup as a proper subgroup, then yeah, it's a simple group. Okay, so after this definition, I want to actually do more like examples. I'm kind of finding a bit difficult that, the pace of this classes is fine, but I'm finding it difficult that, at this rate, I am a bit scared that I won't be able to cover too much ground. So maybe in the future, I can have a little bit longer classes, maybe, if that's something that is acceptable to everyone.
I'm fine with it.
Okay, we'll discuss this because, it'll be good to have, say, I don't know. I know I'm just kind of, working on the assumption that everyone here is pretty serious about their learning in mathematics, and I am very serious about teaching you. So if you're a physics or math major, you're just not here as or even a computer science major who's taking this course, you're not here as just because you have to fill up your, credit hours, right? Okay, so we defined a simple group. Another very important definition is the center of a group. So basically all the elements of a group that commutes with all the elements of the elements of the group that commutes with all the elements of the group is the center of the group. What do I mean? The center ZG of the group G are the elements that commute with all the elements of G. Okay. So it's kind of trivial. It follows very trivially that, Z of G is an abelian subgroup and therefore normal subgroup, right? Because we know that all abelian subgroups are normal subgroups. Okay? Is it clear that this is a group? Or should we prove this? So, okay, let me just break it down. So A is a part of the center of the group if A times G is G times A for all G of the group. That doesn't mean that the group itself has to be abelian. There could be, say, G1, G2, which do not commute. They are not in the center, okay? So if A satisfies this for all G, then A is in the center, okay? So if A is in the, so obviously E is in the center. So E, of course, is obviously in the center. So it has an identity element. So since A is in the center, that means that, A of G is G of A. Now, if I multiply this by A inverse, so then G is equal to A inverse G of A. And then if I'm right multiplied by, say, A inverse, so I get G of A inverse is A inverse G. So this means that if A is, so this means if A is in the center, then we see that A inverse is also in the center. So we have closure, right? And you can show the rest. And therefore we see that Z of G is a subgroup. And because, every element here is commutative, so the multiplication, they commute, so it's an abelian subgroup, and therefore it's a normal subgroup. Okay, and then some definition. The last thing I'm going to do today is that since Z of G is a normal subgroup, that means this is a quotient group, right? We have proved this. Well, I've given you the proof to prove by itself. It's a quotient group. And this has a name. It's called an inner automorphism. Inner automorphism group of G. Okay, so I think I'm going to stop here. And let me just take the attendance very quickly, and then you guys can be on your way or hang around and ask questions. All right, so do we have Rahul?
Yeah, I'm here, sir.
Ahmed Zabir Hussain?
Yes, sir.
Dipro? Medat?
Present, sir.
I think Yashan was here. Yashan, you're here, right?
Yes, sir.
Okay. Shujosh is here. So who's that? Shujosh, yeah.
Dipro.
Oh, Dipro, you're here as well. Okay, good. Sitima?
Present, sir.
Audrey,
Present, sir.
Saif,
Present.
Abdullah,
Present, sir.
Nahi is here. Fiza,
Here, sir.
okay, good. Fahim Firdos,
Yes, sir.
okay, Farhan is here. Ushik Hassan, okay. Proma,
Yes, sir.
okay, awesome. All right, so you guys are free to go unless you have any questions, you can ask me. So, but I will stop the recording. I should have done it before, but anyway.